So the first thing I want to do is I want to examine this chart. It's going to come out kind of small, but it's a very important chart. This is a table of reduction potentials. Notice the word reduction. So I'm going to calculate whether or not a cell made of two half cells, an oxidation half cell and a reduction half cell, I want to know if the overall reaction will be spontaneous, it will run, or non-spontaneous, it will not run. So what I want to do is very simply this. Take some notes. I have a reaction. Reactants goes to products. I write the oxidation reaction. I write the reduction reaction. Easy? Okay. So you have the oxidation reaction and the reduction reaction. Okay. Now, you take the oxidation reaction, and you write it as a reduction reaction. Okay? So, let's review. You have a chemical reaction, reactants plus products. And you write the reduction half reaction and the oxidation half reaction. Then you take the oxidation half reaction and you write it as a reduction reaction. Okay? Then what you do is you look up the reduction potential for the reduction reaction and for the oxidation reaction, but you wrote it as a reduction reaction. So you look up both reduction potentials. Clear? And then you say the overall cell potential is going to equal the reduction potential for the reduction half reaction minus the reduction potential for the oxidation reaction. And that's it. And that is all you need to know for section 2. And let's do some problems just to show you how actually quite simple it is. So let's look at this ready-made conceptual problem determining reaction spontaneity. It's all worked out for you. Let's simply discuss it. So here's the reaction. Zinc plus silver ion yields zinc ion plus silver metal. So it could be it's zinc plus some silver salts yields the corresponding zinc salt plus silver metal. Okay. So you want to understand that it says number 1, identify the relevant concepts. You want to identify the half reactions and calculate the standard cell potential. E0 cell equals E0 red minus E0 oxy. If E0 cell is positive, the reaction is spontaneous. If it's negative, then it is not spontaneous. Now you want to find the oxidation reaction and the reduction reaction. Okay, so zinc solid, zinc metal, zinc zero charge, zinc metal is going to go to zinc plus 2, so it's going to be becoming more positive. So that's going to be the oxidation reaction. The reduction reaction is going to be silver plus 1 to silver 0. That's going to be less positive, so that's going to be the reduction reaction. So now what you do is you take the oxidation reaction and you write it as a reduction reaction. Okay, so you're going to look at it, and you're going to see that you're going to write it zinc as the oxidation reaction. It's zinc yields zinc plus 2 electrons. So you're going to look at it and you're going to reverse it. You're going to write it as a reduction. And it says use table 21.2 to look up the standard reduction potentials for the half reactions. So you see that zinc plus 2 going to zinc metal, zinc zero charge, is negative 0.76. And silver going from plus 1 to silver metal, zero charge, is 0.80. So now you apply the equation. So E naught cell equals E naught red, that's the reduction, and you know that's the silver one, so that's positive 0.8. So it's going to be positive 0.8, and then minus the E naught oxy, which is going to be 0.76, because the oxidation reaction over on the left is zinc yields zinc plus 2 plus 2E, and that's going to be the oxidation. So that'll be negative 0.76. Okay? And so 0.8, positive 0.8, minus a negative 0.76 is going to be plus 1.56. So E naught cell is greater than 0, so the reaction is spontaneous. Now let's do problems 9 and 10. Now, problem number 9 has zinc plus 2 plus chromium metal, zero charge, yields zinc metal, zero charge, plus chromium plus 3. All right. So you want to, and I did this. I wrote this out for you on paper, took a picture of it, and I loaded it. So let's just talk about it until the picture shows up. So the zinc plus 2 to the zinc, that's going to be the reduction reaction. The chromium, zero charge, to chromium plus 3 is going to be the oxidation. So now we have reduction. Zinc plus 2 to zinc 0. Okay, good. That's reduction. And then the oxidation is chromium, zero charge, to chromium plus 3. So reverse the chromium to chromium plus 3. That's the oxidation reaction, but you want to write it as a reduction reaction. Now you look up the two reduction potentials. You look up zinc plus 2 to zinc 0. You look up that reduction potential. And you look up chromium plus 3 to chromium metal. You look up that electrode potential, that potential. That's they're both reduction. They're both written as reduction. So there you have it. The oxidation reaction is chromium 0 to chromium plus 3, and the reduction is zinc plus 2 to zinc 0. But you're going to write the chromium, the oxidation reaction, as a reduction reaction, chromium plus 3 to chromium 0. Now you're going to look that up. Let's look it up. Hold on. So you look them up on the table, and you see the ninth one down, around the ninth one down, is zinc plus 2 to zinc metal, zero charge, and that's 0.76, that's negative 0.76, and then the chromium is going to be the chromium plus 3 to chromium metal is going to be 0.74, that's right underneath that one. And so now you have your two reduction potentials. And you plug them into your equation. You know the equation is E naught cell equals E naught red minus E naught oxy. Plug in the reduction half cell is negative 0.76. The oxidation half cell is negative 0.74. You get negative 0.02. So it's not going to run. It is non-spontaneous. You get a negative value. Remember, positive value is spontaneous. Negative value is non-spontaneous. Let's do another one. Okay, here we go. Cobalt plus 2 plus iron yields iron plus 2 plus cobalt. Okay. Let's see if we can do this quickly. So the cobalt is going from plus 2 to 0. That's going to be reduction. And the iron is going to be going from iron to iron plus 2. That's oxidation. So now reverse the oxidation to iron plus 2 to iron. So you have two reduction reactions. The cobalt plus 2 to cobalt and the iron plus 2 to iron. Remembering that the iron to iron plus 2 is actually oxidation, and the cobalt plus 2 to cobalt is the reduction. Now let's look up the values and see what we can see. So about a third of the way down, it's like 15th or 16th, you see the cobalt is going to be about negative 0.28, and the iron, a few above that, is going to be negative 0.44. Okay, and those are your reduction potentials. Now, just remember that the iron is going to be oxidized. So when you put it into the formula, even though the reduction potentials, you've got to put them in the formula correctly, so that the E naught cell equals E naught red minus E naught oxy is going to be the reduction is going to be negative 0.28. That's the cobalt, minus the iron is oxidation, minus negative 0.44, and that's going to be a positive 0.16 voltage. So that reaction will definitely be spontaneous. So that's it. Now let's do one that's a little different. See if we can figure it out. So, number 11, a voltaic cell is constructed using the following half reactions. Copper plus 2 yields copper, and that is going to be reduction, and that's going to be E naught copper plus 2, okay, and that's going to be positive 0.34. That's going to be reduction, and you have aluminum plus 3 to aluminum. That's also reduction, and that's going to be negative 1.66. Now, so the idea is which one's going to be reduction and which one's going to be oxidation. Now, they're both written as reduction reactions, but one you have to have as an oxidation reaction. So remember, it's E naught red minus E naught oxy. So is it going to be positive 0.34 minus a negative 1.66, or is it going to be negative 1.66 minus 0.34? Well, in order to get a positive number, you don't have to know a lot about math to know that positive 0.34 minus a negative of 1.66 is going to give you a positive value. So it's going to be a plus 0.34 minus a negative 1.66, and that'll give you a positive 2. Okay, so the copper plus 2 to copper will be the reduction half cell, and then aluminum, the reverse of this, then aluminum yields aluminum plus 3 will be the oxidation reaction. And let's see if that works. Okay, so it'll be copper plus 2 plus Al yields copper plus Al plus 3. So the copper plus 2 to copper is going to go reduction, and the aluminum to aluminum plus 3 is going to be the oxidation. And I have it written out. And so I have these two reactions. They're both reduction reactions. And I can clearly see that when I use 0.34, positive 0.34, as the reduction half cell, minus the negative 1.66 as the oxidation half cell, I get plus 2 volts as opposed to negative 1.32 volts if I do it the other way around. Therefore, the reaction will be, therefore 3 dots, aluminum plus copper plus 2 yields aluminum plus 3 plus copper. Not very difficult. You just got to keep your wits about you, because even though the reduction potentials, I can reverse it and use it as a oxidation reaction. Let's do the next one in our head, see what we come up with. Now, I didn't do this out on paper, so let's look. They're both reduction reactions. Silver plus 1 to silver, right? That's a reduction reaction. Copper plus 2 to copper, that's also a reduction reaction. So you have positive 0.8 for the silver plus 1 to silver, and then you have copper plus 2 to copper as the next. Okay, so what is it going to be? What's going to give you a positive number? 0.8 minus 3.34? Is that going to be positive, or is it going to be 0.34 minus 0.8? Well, clearly, the only combination that's going to give you a positive result will be if I say 0.8 minus 0.34. So, the top reaction is clearly the reduction reaction, and the copper reaction has got to be the oxidation reaction. So, I can write the silver reaction as is, that's the reduction half cell, and then I have to write the copper plus 2 to copper in the reverse form and then add the two equations. So let's do that and see what we get. So I would write silver plus 1 plus copper yields silver plus copper plus 2. Get it? So silver plus 1, it's going to be reduced, plus copper, got to reverse that bottom one. So silver plus 1 plus copper metal yields silver metal plus copper plus 2. And that's as simple as that. You can certainly ask me questions next week. We should have at least one class where we could do some review of this. Okay? Thank you for listening. Have a good day. Good luck on your test on Monday, and goodbye.